Welcome back. Today we're going a little bit deeper into Matt's shaper motor here. I think we found the start point, which is about here. To figure out what's going on in this motor, it's relatively simple. Hopefully that's fairly visible. We got 12 coils here. We got 3 phases, so 4 coils per phase. Because they got to be equally distributed, and we have a 4-pole motor, that makes 4 coils per phase. Each of these dashes here is 1 coil, like they are arranged here. So at each 90 degrees we have 1 phase. So these coil 1, coil 1, coil 1, or phase 1, phase 2, phase 2, phase 2, phase 2, and phase 3, phase 3, phase 3, phase 3. On this motor it looks like they're all in series, so the wire comes, let's take phase 1, the wire comes out of this one and goes back into this one. This end goes out and goes back into this one. This end goes out and goes back into this one. So now we have 2 ends. One is here, one is here. We have this one because that's actually on the terminal, but we don't have this one, and I believe it's down here. So, and that applies to each phase, and then you got your 3 phases. On a 2-pole motor the arrangement is a little bit different. You might have two coils next to each other doing 1 phase, and the same on the opposite side. It depends on how many notches you got here in the stator. That's how it's distributed. And equally to a 6-pole motor it's similar. You just got a distribution in arrangement of 6 poles here. That's where the number of poles are coming from. There is also another option. Since we nowadays have relatively cheap inverters available, if we do the maths, each coil is around about 50 volts. So we can arrange them in different configurations. We can put 2 sets of 2 in parallel, which gives us about 200 volts. If we say this thing is 200 volts at 50 Hertz, that's fine. We just set our inverter for that. Or going further, all 4 in parallel will be 50 volts at 50 Hertz. The only difference is 4 times the current, so you need a bigger inverter. That's all you need. So once you're into the motor, you can always evaluate how the coils are wired together and wire it for whatever you need. All you need to do is tell your inverter what you've done, and obviously dealing with the voltages available, and don't forget the current limit of your inverter. It's gonna be the right one. Alright, let's dig into that one here. We need to cut all these, whatever that is. Yeah, so let's cut that off camera, and then we'll come back. This is cracked insulation material, which needs to be looked at as well. I checked the wiring, and it really looks like you can see the wires coming out here on that green thing and coming back to this coil, and we got 2 in between, so that makes all sense. They're all in series. Alright, let me dig that out and I will come back. So hopefully that's visible. I'm filming that through the magnifying glass. Maybe that's better. So again, it's where that light green insulation stuff sits here. I tried to cut it, but it's full of lacquer, so I just cut the wires. Okay, so Here are the incoming wires. I just checked where they go, and then we found that end. It was hidden underneath, so it was pretty hard to see. So let's cut the wires and check if we're right. So we cut the wires. These are our ends, and I can feel the soldering point in that green sleeve here. This is one end, this is the other end, goes to this coil. So if we check continuity between our faces, that's gone now. So we have the right point. And if we check against this one here, and come on, insulate copper wires, here we go, and the other one is here. So we splitted the three faces, and now we got three strings with 4 coils in series. So that motor is 400 volt star, 230 volt delta, or something like that. I don't know what it says here. Maybe it's 440. Can't read it. It says, okay, it says 400, 440. Don't lay it down on the windings because they are so old and brittle. Oops. These windings are so old and brittle, they may break, or the insulation may break. It's not critical if you just break the ears off, but if it splits in between, you've got a phase voltage between those two coils. Each coil is on a separate phase, so you got some relatively high voltage between those. Especially you run it on an inverter, you may have some transients. Should be okay to run that on an inverter because it's at least good for 400 volts. We only run it at 230, so the insulation itself to ground should be okay for that if we don't overdo it. So let's get some wires soldered on, clean it, wire it out. I'm gonna replace those. I think they don't look very nice either. The rubber is really soft and slimy from the grease, so we fit new wires here to that and wire it out to the terminal. Once we connected everything up, we just put all the wires back and just use some string and bind it back and see how it looks after cleaning. If there are some exposed, scratched parts, which I don't believe because it appears the motor was never open. We just cover that with epoxy or so. But most important, if the edges of the insulation look good, all these corners here, and that's all there, we shouldn't have an issue with shorts to ground. So that confirms this motor was in star. Don't know how, hopefully that's visible. So what we had our 4 coils on each face, and they were tied together in the middle, hidden. So we are opening this point and wire each coil out to the terminal, so we can switch that in delta for the low voltage. And I just peeled off the insulation, and we can see the 3 wires are coming together here. So we're gonna strip the other 2, put some proper wires on, and replace those rubber insulated wires as well, because they are strange, don't know. with new ones, just to make it electrically safe. And then we give it a clean insulation test, and it should be done so far. Alright, that's it for today. We'll carry on at another date when I got some time. Dinner time. Thanks for watching. Thanks for subscribing. Until next time.